Thank you for the introduction. Hello, or hola. I also speak Spanish, and I'm often confused in Rome as an Italian speaker, so I try my best to understand what's happening. But as Aizgo said, I'm an engineer at One Medical, and today I'd like to give you an overview of the challenges my team has faced in migrating an electronic health record application from AngularJS to Angular 7 today. But before I do that, I'd like to introduce myself as well as the agenda for this talk. So I can be a really chatty person online. If you look at my Twitter feed, there's thousands of tweets. But I have to admit that public speaking is a huge challenge for me. Despite that, I have many hobbies outside of programming. So if you'd like to chat about any of these topics after the talk, please come to me, and I'm happy to discuss. For the rest of the talk, I will be touching on these topics. First, I'd like to give you context about my role at One Medical. Then I'll set the context for what I mean when I talk about change detection. After that, I'll put change detection in the context of an electronic health record application. And then I will reflect on what my team would have done differently when we were migrating the application. Next, I'll go over two migration paths, being the upgrade and downgrade module, and then some strategies for manual change detection to support change detection after your migration is over. To wrap up, I'll leave you with some final thoughts and recommendations. For me, One Medical is an exciting place to be as a front-end engineer. The applications we build facilitate information exchange about our patients. This includes a patient's vitals, so blood pressure, heart rate, weight, as well as medication history, lab results, and messages between them and the clinical staff. We are a full-stack healthcare company in that we design and build the experiences we believe are best for our doctors and our patients. And this responsibility is very uncommon, especially in healthcare in the United States, where healthcare technology is often third-party bloated applications that are rarely updated. So as an engineer at One Medical, I'm very excited about the ability that we have to transform the healthcare experience, not only for patients, but for doctors as well. So now that you have a better idea about my role at One Medical, I'll give you my basic understanding of change detection. Change detection is what keeps the UI in sync with data as changes happen. In AngularJS and Angular, we're accustomed to automatic change detection during a component's lifecycle. For the application that I work on, this is often saving form data and showing some feedback on the UI to the user that those saves were successful. While automatic change detection sounds like a great thing, it challenged my team as we were migrating our electronic health record application. This application is used by hundreds of doctors across the United States to read and update information about one of our many thousands of patients at a time. Automatic change detection introduces a visibly laggy experience for a user when handling a data-intensive application. My team wishes it had known change detection would have had a large part in affecting our migration all along. If we were to start the migration again, we would have a better sense of what decisions to make. When we started, we simply chose the first of the two options presented by the Angular documentation without really thinking too much about it. These two options are the upgrade and downgrade modules. And when we talk about these two modules, we refer to a hybrid application running AngularJS and Angular on the same page. One major distinction between the two is that change detection acts a little bit differently in your application. So the upgrade module will run change detection more frequently in order to ensure that both frameworks are in sync. It does this by running the frameworks in the same execution context, or what the Angular framework calls a zone. This inevitably results in more change detection cycles than necessary and a tight coupling between the two frameworks. Unfortunately, change detection is detrimental to runtime performance and user experience. And with the first release of our Hyperiod application, we immediately received reports of slow typing. These reports were coming from doctors that were note-taking patients' complaints in their office or over video chat. And some of them even reported that typing, the text that they had typed would appear even 10 seconds after they had typed it. Knowing how frustrated I get when Visual Studio Code slows down, hearing this would make me want to pull my hair out. We spent several days profiling API endpoints, thinking that maybe we had some slow queries in the backend crop up out of nowhere, as well as looking at scripting time in Chrome DevTools to see if there was some memory leak somewhere in our code base that we hadn't noticed up until now. And we finally realized that the automatic change detection included in the upgrade module was the culprit. With that discovery, we said goodbye to the upgrade module and rewrote the code that bootstraps AngularJS and Angular using the downgrade module. After we understood the differences between the two migration modules, we turned to the downgrade module to bootstrap our application. We immediately saw improvements in typing, since the downgrade module only runs change detection when the inputs of a component change values. There was weight lifted off of our shoulders, but this change was not the end of our worries. While there are less change detection cycles, this means that the team also has to be responsible for running change detection in some areas where you need the frameworks to communicate with each other. We thought we were out of the fire, but despite the downgrade module providing us with faster change detection strategy, it's also trickier. We were often faced with bugs where AngularJS and Angular were expected to notify each other of changes, but they no longer were. In this example, we were using a Boolean across both frameworks to notify that a column must expand and take the full width of the page. And while AngularJS was modifying the value, Angular was completely oblivious to the change, so you could click the button all day and nothing would happen. Thankfully, there are strategies to ensure that this change detection happens. Angular provides you with what it calls change detection strategies. The one that it uses in the downgrade module is the onPush strategy. By implementing the onPush strategy in your components, you can support performant change detection after your migration is over and you remove the downgrade module. Here's an example of a component with change detection set to the onPush strategy. Now I will talk to you about 3 manual change detection strategies. The first being set timeout, and then 2 methods of using change detector ref. Change detector ref is a complicated thing for me to say, but it allows you to control change detection the Angular way. So using it is by no means a hack, whereas set timeout may be. Set timeout is not a recommended way to cause change detection because it redraws the entire component tree on the page. But it does, for me personally, provide a really quick way to debug what might seem like a change detection bug. And on my team, we try to avoid using it unless it's absolutely necessary. In this case, it was necessary because we wanted to do some toggling of a Boolean that enables a global navigation menu. The menu is not toggled too frequently, so this usage of set timeout is not too expensive for us. The next manual change detection strategy is detect changes, where you can essentially refresh the change detection cycle immediately after you mutate data on a component. In this example, we want to show that there's an error and file uploading has completed immediately after we receive those values. So we run detect changes. The next is mark for check. And it's great for asynchronous tasks where you don't want to immediately trigger change detection, but you do eventually want for those changes to be checked. In this example, we modify some properties on a component in an observable subscription. We don't immediately want to run change detection, but we do want these changes to eventually be reflected later on. So now that you know a little bit more about manual change detection strategies, I will leave you with some final thoughts. If you're upgrading a large application, it's worth understanding how the upgrade module works, but you're better off using the downgrade module. The Angular documentation is a great resource for making more distinctions between the two. Once you're done with the migration, you will delete the downgrade module and keep the change detection strategy if you apply it on an application level or per component basis. This ensures smart change detection management well after the migration is completed. And finally, my team and I made the mistake of using development and pre-production environments that were not loaded with the same amount of data our doctors deal with every day. We could have caught the issues with performance before our users did had we seeded more data in these environments. It's easier to understand now that the more component instances you have on a page, the more slow your application will get when you have automatic change detection. To wrap up, these are some links that I recommend to get a much deeper and thorough understanding of change detection. Thank you for taking the time to listen to what I had to say. And if you'd like to continue the talk after the conversation after this talk, please come talk to me.